Picture this. You step outside on a clear winter morning in Salt Lake City, expecting fresh mountain air. The sun is climbing over the Wasatch Mountains. The streets are wet from overnight snow. Everything should feel pristine. But instead, your lungs fill with something far darker. Particles of mercury, arsenic, and lead drifting across the Wasatch Front from what used to be one of America's most resilient inland seas. You taste mineral dust on your lips. Your throat feels raw. This is the story of how the Great Salt Lake disappeared. Not slowly, not someday. Now. Utah's 3,300 square mile sea has lost 73% of its water in less than 2 centuries, and what remains is becoming a toxic bomb that's actively poisoning the people living on its shores. Millions of people downwind don't even know they're breathing a lake. And once you know that, you can't unknow it. You'll taste it every winter. You'll feel it in your chest. Welcome back to the channel. If you haven't subscribed yet, hit that button now, because what's happening here is the blueprint for environmental collapse anywhere water is controlled by agriculture and institutional greed. This isn't a documentary about yesterday. This isn't climate anxiety disguised as science communication. This is about what happens when an entire region runs out of water and a dying lake starts weaponizing dust against 2.5 million people living directly in its path. This is about a state government that knew exactly what was happening and did almost nothing until the crisis became undeniable. This is about the hidden machinery of water theft in the American West, and why the Great Salt Lake matters to anyone who cares about the future of the region or the future of the planet. The Great Salt Lake wasn't always in crisis. For millennia, it held steady through drought and flood, maintaining an almost impossible chemical balance. Empires rose and fell around its shores. Indigenous peoples thrived on its bounty for thousands of years. Then, white settlers arrived in the 1840s, and within a single human lifetime, they diverted nearly every major river feeding the lake. They turned a sea into a slow-motion catastrophe that we're only now beginning to fully understand. By the 1850s, the lake covered approximately 2,400 square miles. Today, it covers roughly 1,000 square miles. That's not a reduction. That's an erasure. That 73% loss of water in less than 170 years is why we're here now, watching a lake that should have been protected get weaponized against the people who drained it. So how did we get here? The math is actually simple and deeply damning. The Great Salt Lake Basin receives water from 3 major river systems: the Bear River from the northeast, the Weber River from the east, and the Jordan River flowing from Utah Lake in the south. These rivers once flowed freely into the lake, maintaining a delicate equilibrium between water input and evaporation. That balance had existed for millennia. It was stable. But starting in the 1870s, settlers in Utah began diverting massive amounts of that water for irrigation. Agriculture needed water, farms needed water, orchards needed water, cities needed water. The stakes kept rising. Then came the Colorado River Compact of 1922, a federal agreement that guaranteed Utah a specific water allocation. Sounds good in theory. But here's the fatal flaw. That allocation was calculated based on the wettest years on record, the from 1905 to 1922 water years, which were the wettest in a century. It was a calculation made at the peak of an unusually wet cycle, essentially locking in an impossible expectation. When the climate shifted back to drier conditions in the 1980s and the 1990s, and then catastrophically dried out in the 2000s, Utah was chasing a ghost. The state was allocated water it could never sustainably take, and Lake Powell and Lake Mead collapsed. The Great Salt Lake was left holding the bag. Here's what nobody talks about in polite company. About 80% of the water loss from the Great Salt Lake is directly caused by irrigated agriculture. Not cities, not industry, farms. Billions of gallons per year are diverted to grow alfalfa, hay, corn, and other crops that mostly end up feeding livestock or getting exported to other countries. One crop alone, alfalfa, uses more water in Utah's portion of the Great Salt Lake Basin than the entire state's human population combined. It's staggering when you do the math. A single dairy cow in Wisconsin eating alfalfa that was grown in Utah and irrigated with the Great Salt Lake's dwindling water supply. That's the scale and the absurdity of the theft. A cow 2,000 miles away is drinking the Great Salt Lake. Modern irrigation technology was supposed to solve this problem. More efficient systems, drip irrigation, computer-controlled watering, but it hasn't. It's just made the theft invisible. Water is pumped through systems so efficient that most Utahns don't see it leaving. Farmers don't see the consequences in their fields. Urban dwellers don't see the connection between their grocery stores and the dying lake. They just see the dust. They just feel it in their lungs. But here's where it gets truly terrifying. What happens when a salty inland sea starts drying up isn't a slow fade to nothing. It's a catastrophic release of centuries of toxic accumulation. The Great Salt Lake lakebed contains centuries, literally centuries, of accumulated salt, minerals, and industrial waste. Mining runoff from the Wasatch Range. Agricultural chemicals that have leached through the soil. Heavy metals that settled on the bottom over decades. Mercury from old coal plants. Lead from industrial discharge. Arsenic from mining operations. All of it just sitting on the bottom, inert because it was underwater, locked in sediment and salt. As the water level falls, these exposed surfaces become open wounds in the landscape. The lakebed that was pristine and underwater for thousands of years is now exposed to wind and weather. And every time a strong wind blows hard in the Wasatch Front, and it does, frequently, that poisoned lakebed becomes airborne. It becomes a weapon. The composition of Great Salt Lake dust reads like a toxicology textbook written by someone who wanted to cause maximum damage. Mercury, arsenic, lead, cadmium, antimony, copper, zirconium, selenium, manganese, iron, lithium, uranium, plutonium, and a host of compounds and microorganisms that have no business in your lungs. Salt Lake City experiences about 15 dust storms per year now. 15 years ago, there were none. 0. The frequency is accelerating exponentially as the lake gets shallower. Scientists at the University of Utah found that the dust itself is pro-inflammatory. It doesn't just sit inert in your lungs like regular dust. It triggers your body's immune system to attack your own airway cells. It activates TRP receptors that promote damage to the epithelial cells lining your airways. Chronic inhalation of this dust leads to systemic inflammation, a hallmark of aging and the biological foundation of nearly every chronic disease: heart disease, dementia, cancer, autoimmune disorders, Alzheimer's disease, Parkinson's disease. We're talking about premature aging at the cellular level caused by breathing dust from a lake that didn't have to dry. Who breathes this poison? The Wasatch Front metropolitan area has a population of roughly 2.5 million people, and they're directly downwind of the exposed lakebed. But the impact extends far beyond Salt Lake City and the immediate surrounding area. Dust from the lake has been detected in Colorado, Wyoming, and as far west as Nevada, carried by prevailing weather patterns across the Intermountain West. One large dust storm can impact millions of people across the entire Intermountain region. The dust gets caught in weather systems and jet streams that can carry it hundreds of miles, crossing state lines and reaching populations that have no idea where their air pollution is coming from. And it's not random who suffers most from this exposure. Research from multiple sources shows that communities of color, Pacific Islander, Hispanic, Black, and Native American communities, are disproportionately exposed to the toxic dust. They live closer to the lakebed because property values are lower in those areas, making housing affordable only in the zones directly impacted by dust transport. They have fewer resources to filter their air or install expensive HEPA systems in their homes. They're paying the price for Utah's water mismanagement with their health, their children's health, and their lifespans. Environmental racism isn't just a concept. It's not something to debate in abstract terms. It's measured in respiratory illnesses and premature deaths among specific communities. What does that actually mean in real terms for human health? Respiratory illnesses are climbing in Salt Lake City. Asthma rates in children are spiking, some of the worst in the nation. Cardiovascular disease correlates with dust exposure. Physicians in Utah have been sounding the alarm for years, documenting an increase in previously rare conditions. But the state moved slowly, too slowly. By the time officials really started paying attention, the damage was already accumulating in people's lungs. Dr. Robert Payne, a pulmonologist at University of Utah Health who studies the health impacts of Great Salt Lake dust, has documented cases of toxic dust exposure causing permanent lung damage in previously healthy adults. These aren't theoretical risks pulled from epidemiological studies. These are real people who moved to Utah expecting clean mountain air and are now struggling to breathe. They're real children going into asthma clinics with inflamed airways. They're real workers in outdoor jobs who have no escape from the dust. And that's because stopping the dust means making agriculture give back water. And in the American West, that's a political third rail that nobody wants to touch. Now let's talk about what dies when a lake disappears. The Great Salt Lake isn't like most other lakes. It's a closed system, a terminal lake with no outlet to the ocean. Everything that flows in stays in, which is why it becomes progressively more salty. The normal ocean has about 35 parts per thousand of salt. The Great Salt Lake currently has about 65 to 70 parts per thousand, nearly twice as salty as the ocean. That extreme salinity creates a unique ecosystem that can't exist anywhere else on Earth. It's a biological anomaly. At the heart of that ecosystem is the brine shrimp, Artemia franciscana. Microscopic crustaceans barely the size of a rice grain that are literally invisible to the human eye unless you're looking closely. Yet these tiny creatures are the foundation of an entire food web. They feed on algae. The algae feed on microbialites, strange living rock-like structures built by cyanobacteria that have been growing in this lake continuously for 10,000 years. These microbialites are among the oldest living structures on Earth. They're a living link to an ancient world. Eared grebes are water birds that migrate through the Great Salt Lake every fall on their way south to the Gulf of California. Their entire migratory route, thousands of miles, depends on one critical stopover, the Great Salt Lake. They need to stop here. They need to gorge themselves on brine shrimp to build up enough fat reserves for the brutal final flight south. A single-eared grebe will eat up to 30,000 brine shrimp per day while at the lake, just shoving them down their throats non-stop, building the subcutaneous fat that will carry them across deserts and mountains. Approximately 90% of the entire North American eared grebe population, millions of birds, depends on this single lake. No other migration hotspot on the continent is that critical for that many birds. This isn't redundancy. This is a single point of failure for an entire species migration. But in 2022, when salinity spiked as water levels fell and evaporation concentrated the salt, the algae production collapsed. The brine shrimp populations crashed. Starvation followed, and every subscriber is automatically entered in our monthly giveaway for a branded hoodie. Details in the description. But beyond the free merch, the real cost that year was measured in dead birds, hundreds of thousands of dead grebes that couldn't complete their migration. During the 2022 to 2023 harvest season, brine shrimp cysts harvested hit roughly 19 million pounds. That's about 54% of the 10-year average. Think about that statistic. The industry that commercially harvests these shrimp for aquaculture generates $60 million annually in Utah alone, employing about 150 seasonal workers. But more importantly than the money, the Great Salt Lake is the world's single largest source of brine shrimp eggs, accounting for 45% of the global supply. Nearly half of all brine shrimp on Earth come from this lake. Those eggs get shipped in refrigerated containers to aquaculture systems worldwide. They feed farmed fish, such as salmon, tilapia, and shrimp. Those farmed fish feed humans. The brine shrimp from Utah's Great Salt Lake help produce 20 billion pounds of seafood every year. That's the weight of 10 million cars in seafood. Remove the Great Salt Lake from this equation, and you're removing a critical link in the global food system that feeds tens of millions of people directly. This isn't some niche environmental issue. This is a food security crisis waiting to happen on a global scale. But the economic damage doesn't stop at brine shrimp. Scholars have calculated the broader economic losses from the lake's decline could reach between $25.4 billion and $32.6 billion over just 20 years, with more than 6,500 jobs lost across the region. The ski industry depends on snowpack in the surrounding mountains. That snowpack depends on the water cycle. A dying lake means less atmospheric moisture in the region, which means less snow in winter. Less snow means struggling ski resorts, fewer tourism dollars, and entire communities that depend on winter recreation going under. Park City, one of the most expensive ski towns in the country, depends on reliable snowpack that's increasingly dependent on the Great Salt Lake's contribution to atmospheric moisture. The Great Salt Lake is the engine of Utah's economy, and we're letting it shut down in real time while we watch and argue about water rights. So what did the state do when they realized a $250 billion emergency was unfolding before their eyes? By 2022, after years of denial and incremental tinkering, Utah declared a water conservation emergency, the first time the state officially admitted the crisis was real and needed immediate action. The state legislature appropriated emergency funding, though environmental groups and water experts argued it wasn't nearly enough to address the scale of the problem. In 2023, the state made historic changes to water law, reforms that should have happened 50 years earlier but were politically impossible until the crisis became undeniable. They expanded the definition of beneficial use to include environmental flows to the lake itself, a revolutionary concept in the West where water has always been treated as something to extract and use, never to leave alone for environmental purposes. They reformed the use it or lose it rule that had forced farmers to waste water or lose their water rights forever, a system that perversely incentivized waste. The state authorized split-season leasing, allowing farmers to lease water for part of the growing season instead of the rigid all-or-nothing arrangement that had dominated farming for a century. And most significantly, the state launched a water leasing program that pays farmers actual money to send water to the lake instead of using it for crops, essentially buying the water back from the people who had diverted it. In the latest year, the state secured 163,468 acre-feet of water for the lake through this program. That's a massive jump, up from roughly 18,000 acre-feet in 2021 when the program started. Progress is visible, and for the first time, it's accelerating. But here's what we need to be brutally honest about. These efforts, while significant and genuinely revolutionary for the West, are not enough. Not even close. The lake needs a sustained 800,000 acre-feet of additional water annually just to return to healthy levels by 2055. That's the kind of commitment that requires rethinking the entire agricultural model of the region from the ground up. That means less alfalfa, less hay, fewer water-intensive crops. It means paying farmers generously enough to leave ground fallow and accept that not all land should be farmed. It means making agriculture productive in a desert by actually acknowledging that we're in a desert. Some farmers are stepping up and participating in the water leasing program. Some are refusing, entrenched in the old way. And the state is caught between a regional economy built on water it doesn't have and an ecosystem that's literally dying in real time, on a visible, accelerating schedule. The comparison to other dewying lakes around the world is instructive and deeply ominous. The Aral Sea, once the fourth largest lake on Earth, covering 68,000 square kilometers, was diverted by Soviet irrigation projects in the 1960s to grow cotton in the desert. By 2007, it had shrunk to 10% of its original size, split into 4 separate bodies of water because the water input completely stopped. The salinity became so extreme that it killed the fishing industry entirely. It fell from 40,000 tons of fish per year to 0. The exposed seabed became a source of toxic dust that poisoned the region and caused respiratory disease, cancer clusters, and reproductive problems. The Aral Sea's collapse took out an entire regional economy and displaced millions of people from communities that had existed for centuries. Lake Chad in Central Africa has shrunk by 90% since the 1960s due to climate change, combined with irrigation, drying up a water source for between 20 and 30 million people. The Salton Sea in California, formed accidentally in 1905 when an irrigation canal broke, is now 25% saltier than the Pacific Ocean and completely toxic due to agricultural runoff. Fish can't live in it. Birds that land on it die from disease. These aren't cautionary tales you can dismiss as far away or irrelevant. They're precedents. They're blueprints for what happens when we let inland seas die. And the Great Salt Lake is on that same trajectory. The biggest question hanging over all of this is whether Utah and the American West will make the hard choice before it's too late. We have time. Not much time, but some. If the current deficit of 1.2 million acre-feet per year continues at its current rate, the lake as we know it will disappear in 5 years. Not centuries from now, not decades from now. 5 years. That's the timeline. At that point, we're not talking about a crisis. We're talking about an environmental collapse that echoes across generations and international borders. But there's another version of this story, one where Utah makes the tough political choice, where agriculture transforms to match hydrological reality, where water is treated as the finite, precious resource it actually is, instead of a public good to be infinitely exploited for profit. The residents of Salt Lake City, the farmers of the Great Salt Lake Basin, the brine shrimp harvesters, the public health workers treating respiratory diseases in clinics across the region, they all know what's at stake. They live with the consequences of water policy every single day, every single hour. When you step outside on a dust day and taste dust and salt on your lips, you're tasting a century of bad decisions. You're tasting the visible consequence of a region that exploited its water beyond sustainability. When a child is diagnosed with asthma in the Wasatch Front, that child is breathing the cost of prioritizing agricultural exports over a livable region. That child's chronic illness is the bill being paid for the alfalfa shipped to dairy farms in other states. When a brine shrimp harvester realizes that this season will be the last season because salinity has finally crossed the threshold where reproduction fails, they're confronting the end of their livelihood and the end of a biological system that has existed undisturbed for 10,000 years, a system that predates human civilization. This is what happens at the intersection of climate change, agricultural addiction, and water denial. You get a lake that loses 73% of its water in less than 2 centuries. You get a region of 2.5 million people breathing toxic dust filled with arsenic and mercury. You get a global food system that depends on brine shrimp from Utah suddenly at risk of catastrophic collapse. You get an entire state's economy hanging by a thread because we were too comfortable to ask the hard questions when there was still time to change course. And when 25 million people breathe poisoned air from a lake they never thought would disappear. grab your free disaster preparedness toolkit. The link is in the description. You'll need it more than you think. The Great Salt Lake is still dying. But unlike the Aral Sea, unlike Lake Chad, unlike the Salton Sea, we still have the opportunity to choose a different ending. That choice expires in 5 years. What we do between now and then will determine whether the Great Salt Lake becomes just another cautionary tale of environmental collapse, a case study taught in universities about how we failed, or whether it becomes the moment the American West finally faced reality and transformed. That's not a metaphor. That's not hyperbole. That's the timeline. That's the stakes. And that's why we're still talking about this lake, why we'll keep talking about it until something changes, and why you need to understand what's happening here before the dust gets any thicker.